Good morning, good afternoon, good evening. Hope we are all well. Today we are going to discuss the problem Doremy's Paint 3. This is the sixth problem in the TLE Eliminators CP sheet. This problem is 800 rated. So let's start. Let's first read the problem statement. An array of positive integers is good if all the sums of two adjacent elements are equal to the same value. More formally, the array is good if there exists a k such that the sum of adjacent, that is b1 plus b2, is equals to b2 plus b3 and so on. Doremy has an array of length n. Now she can permute its elements, that is, she can change the order however she wants. Determine if she can make the array good. We need to print yes if we can make the array good, no if we cannot. So let's go over the things. We are given this condition. So let's work on this condition. We are given b1 plus b2 equals b2 plus b3 equals b3 plus b4 and so on. So on looking at this statement, we can very well say that, like this statement, we can very well say that b1 equals b3, right? We can just cancel b2 b2 and b2 plus b3 equals b3 plus b4. b3 cancel, b2 equals b4. If we go on like this, we can easily say that b1 equal b3, b equals b5 equals b7 and onwards. b2 equals b4 equals b6 equals b8 and onwards. So one thing that is clear from this is that we can have at most two distinct elements. At most two distinct elements. So one is this, and the frequency of them, like if these both only two elements, if both of them are the same, then we can have any and the frequency doesn't matter. If they are different elements, then the frequency can be at most n by 2, like because b1 plus b2 plus b3 and suppose bn, all of them are n elements and b1 and these are equal. So a into b1 plus x into b2 equals n elements. A plus x equals n elements. So both of them are equal, and for the sum to be equal for all of them, both of them need to be at most n by 2 elements. So this is another piece of information that we can see, like they can be at most two distinct elements at most, and the frequency can be n by 2. So why am I using an upper bound? Let's suppose we have 5 elements. So by 2 and upper bound is 3. So we can have an element with frequency 3 and an element with frequency 2. Like suppose we can have this 3, 2, 3, 2 and 3. We can have this. So the sum would be 5. So I think you got the approach. So let's just see a little bit of pseudocode. We'll have an input, that is n. We'll have an input array arr of n. So now we need to calculate the frequency for all of them. So we'll have a map that will show the variable and the count of that variable, like the frequency of that variable. Now if the size of the map is greater than 2, that means more than two distinct elements, then the answer is no, directly no. If the size is 1, then the answer is for sure yes. Otherwise we can just find the difference in the frequencies. So if the absolute difference of frequency 1 and frequency 2 is greater than 1, if the absolute difference is greater than 1, that means one of the frequencies is less than n by 2 and one is quite greater than n by 2. So then in that case we won't be able to get a single k value. That's why this case we'll have an answer no, else we'll have the answer yes. I think you got the approach. So let's move on to the coding part now. Let's code it up. I'll get my boilerplate here. So we are given a single input. We are given a single input and we are given a vector of integers. We'll take all the inputs. And we'll make an unordered map. and we'll increment the frequency of each element. So it can be done like this. Now we'll check if the number of distinct elements is greater than 2. If mp.size is greater than 2, then the answer would be no. If distinct elements equals 1, only one single element is present, then the answer is always yes. We'll have a continue here. Now this is the case where the size is 2. So now we need to check the frequency. So the frequency 1 and frequency 2. So I'll first get the frequencies. So the first frequency would be frequency 1 is the beginning of the map and the second element of the map. The second frequency would be, I'll increment the first pointer by 1. So this points to the second element in the map and I will have the frequency for that. Now I'll take the absolute difference for both, and if the absolute difference is greater than 1, that means our answer is no. If it's less than 1, or if it's 1 or 0, that means we can have the answer as yes. Let's code it. Absolute difference of frequency 1 minus frequency 2 is greater than 1, that means our answer is no. Otherwise our answer is yes. So let's try the sample test cases now. Okay, it should be yes, yes, no, no, yes. So our code runs for the sample test cases. Let's try to submit it. Submit. So yes, it got accepted. I hope you got the explanation and the solution. The submission link will be in the description section. Comment down what was your approach for solving these problems. If you have any suggestions for me, please comment down that also. Thank you for watching. Like the video and subscribe to my channel for such coding tutorials. Thank you.